Welcome back to your favorite YouTube channel, A1 Tutor, where we pick previous questions from the WAEC and then we help you in solving them. So today we have a question on the board. So let's see how we can handle it. 2024. Mercury of density, so this is density, is poured in a container of uniform cross-sectional area of 40 centimeters square to a height of 20 centimeters. So the total pressure exerted on the base of the container is this figure. So this P is Pascal, and that is a pressure, a unit for pressure. So calculate the mass of mercury in the container. So number 2, we are looking for the pressure exerted on the surface of the mercury. So this question means atmospheric pressure, because it's only atmospheric pressure that acts on the surface of liquid. So let's go to the first one now. Density in physics can be calculated using mass over what? Volume. So, and this is the mass we are looking for in the first question. Now, but we can break this one down because volume was not mentioned. But instead, we were given area and length. Area and what? Height. So we can say volume is the same thing as area times height. Because volume means length times breadth times what? Height. And area is length times what? Breadth. So we can replace our volume with A times what? Height. Okay, so let's go down. Our density is equals to mass is what? Okay, the value for density now. What's the value? I have 13.6 times 10 raised to power 3. Then equals to, I am looking for mass. Then our area is 40 centimeter square. We need to convert it to meter. So it's going to be divided by 100 in 2 times. 100 in 2 times. So divide this by 100 first time, meaning that is 1 length. You divide by another 100 because area has to do with 2 lengths. So you are dividing this number by 100 in 2 times. So let's do that now. 40 divided by 100 and then divided by another 100. So 40, that is how you convert area to in centimeter to a meter. So that value you are given, you need to divide that value by 100 2 times. So here I think I have 0.004. That's what I have. Now you need to convert the height as well from centimeter to meter. So this one is going to be 20 divided by 100 just one time. That is 0.2. Think. So what I need now is to cross multiply. So everything here, we multiply everything here, and that is our mass. So our mass now is equals to 13.6 times 10 raised to power 3 times 0.004 times 0.2. That is our mass. So let's multiply it. You can also try your own calculator as well, but this is exactly what we want to multiply out. This times this times this. So let's see what the calculator values give. So our mass is equals to 10.88 kilogram. So we are done with our mass. Now let's get the second question. The second question says we can calculate the pressure exerted on the surface of the water liquid. I told you before the commencement of the solution that the pressure that always acts on the surface is the atmospheric pressure, and that is when you have water in a tank and you open the tank. So the atmospheric pressure is the pressure from the atmosphere that will always act on the surface of the liquid because the tank is what? Open. So there is atmospheric pressure acting on the surface of the. So how do we go for atmospheric pressure? Some of the time Pascal give it as a constant, but here we are asked to find it. So we will assume as if we don't know it. But most of the time, if you need it and you are not asked to calculate it, you need it to solve a particular question. The value is always 1.01 times 10 raised to power 5 Pascal. That's the value. But here we are asked to find it. So let's see. So for us to get atmospheric pressure, we need total pressure. So total pressure is equals to atmospheric pressure plus this. That is pressure in liquid. So this is formula for calculating total pressure. So total pressure is mentioned in the question. Thank God. We have it as 1.42 times 10 raised to the power 5. So that is total pressure. 1.42 times 10 raised to the power 5 equals to, this is the one we are looking for now. Atmospheric, you can see ATM, atmospheric pressure plus this. So this is the formula for pressure in liquid. Now, this one is density, this one is acceleration due to gravity, and this one is what? I. So let's have all of them now. I have 1.42 times 10 raised to the power 5 minus density times gravity times what? Height is equals to our atmospheric what? Pressure. Therefore, our atmospheric pressure, this is P, atmospheric pressure is equals to 1.42 times 10 raised to the power 5. Now minus, open bracket, our density is 313.6 times 10 raised to the power 3. Our acceleration due to gravity is 10. And our height, I think we have calculated for height. Our height is 0.2. So let us multiply everything here together now. So to go into that. So atmospheric pressure or pressure acting on the surface is equals to 1.42 times 10 raised to the power 5 minus, okay, let's go for everything in the bracket now. So 13.6 times 10 raised to the power 3 times 10 times 0.2. So let's have everything in the bracket now. So you can try the calculator yourself, but this is what we can get now. But at your own convenience, you can try the calculator. So 27,200. That is what we have here. Okay. So this is equal to, okay. Can we do the subtraction now? Can we do this into this? So we can move this one to 5 times. That's the meaning. We can move it 5, but let us use calculator to save our time. This, then minus this. So let's see what we can get. You can try yourself. You can try it yourself. You can try it yourself. According to what you have here, I have 114,800. That is what you have here. 114,800. So don't forget I told you that atmospheric pressure, normal is atmospheric pressure that this man called Pascal gave us a constant number, and the number is 1.01 times 10 raised to the power 5. Now if you move this thing as well, let's say 1, 2, 3, 4, 5. So that is it. So this one gives us 1.1. But normal number is 1.0, so which means it is also very close to the answer. So our answer now is 114. 114. I have 114. So you can confirm that yourself with calculator. But this is the analysis we can take to get that answer. So if you need any of those, so I have 114,800 pi. But you can confirm that at your own convenience. But these are the formula you need, and those are the steps you need to take in getting this answer. Thank you. We meet in the next class.